All right, let's go ahead and simplify this big old rational expression. The way that we'll do that is we'll try to find common factors in the numerator and the denominator and cancel. I know some of you would like to cancel this m squared with this m squared, but you can't. And some of you would like to cancel this 3 with this 6 or this 30 with this 6, and you can't. If there was a 3 that was multiplied times these guys, then we could go and cancel those 3's. But we're going to have to factor. So first thing we'll do is we will factor this m squared plus 11m plus 30. So we get 30 here and 11 here and 5 and 6. And that'll give us this. Oops, not x. It'll be 6m plus 5, m plus 6. Let's go ahead and rewrite all this up here. And then down below we factor and we hope that we can do something neat. So m squared minus 25, we can rewrite that. That's a difference of squares. So we can rewrite that as m plus 5 times m minus 5 all times m minus 6. So it looks like there's a bunch of stuff we can cancel here, doesn't it? Look at this m plus 6 and m minus 6. Those should be cancelable, right? No, they're not, sorry. But this m plus 5 and this m plus 5, totally cancelable. So we go ahead and strike those two out. We put a 1 up here and a 1 down there. And then we can rewrite this whole guy like such. It should be 3m times m plus 6 over m minus 5 times m minus 6. And although it looks like there's some stuff we could still cancel and we really want to, there's nothing and we can't. So we stop here and we say this is as simple as it gets. Now, at this point I want to introduce something new. I'd like to talk about domain and range. So in the past, we looked at functions that looked like this, y equals 2x plus 3, and we said the domain for this guy is all real numbers, and the range for this guy is all real numbers. And we looked at things like this, y equals 3x squared, and we said the domain for this guy is all real numbers, but the range is not all real numbers. This guy, you know, it's a parabola, and therefore it has a minimum point. Since it has a positive leading coefficient, and so the range has to be from the minimum point up, and that's it. So at this point we learned that range can be kind of interesting, but the domain for both of these guys was all real numbers. So why did we ever, if domain is always all real numbers, then why do we even care about it? It's always all real numbers. Well, now what we learn is that it's not always all real numbers. It turns out for something like this, if our main variable m it could have been x. If our main variable is in a rational expression and we have that variable in the denominator, then there are limits on what the variable can be, what values it can be. So for instance, if we have 1 over x, there is a bit of a problem if x equals 0. So we say this is perfectly valid. In fact, we might even say something like this. F of x can equal 1 over x as long as x does not equal 0. Okay? And for those of you who are wondering, well, why is that? Well, try it on your calculator. Try doing 1 divided by 0 and see what you get. I suspect what you're going to get, your calculator is either going to say error, or it's going to say divide by 0 error, or domain error. And all of those relate to the idea that the domain is limited here. X cannot be all real numbers. It cannot be 0. And the reason why is we cannot have 0 in the denominator of a fraction. So, take a look at this guy. If we look at the denominator of this fraction, there are two values for m that would make the denominator 0. So if we wanted to rewrite this guy as a function, if we wanted to say this is f of m equals all this stuff, then we would have to restrict the value for m. We'd have to say that m could be all real numbers except for m cannot be equal to 5 or 6. And that is something that we're going to have to deal with when dealing with rational expressions and rational equations, is that if we have variables in the denominator, we will have to limit our domain. And we limit our domain in a way so that we never end up with a 0 in the denominator. So this is a perfectly legitimate function as long as m is not equal to 5 or 6, because m equals 5 would make the denominator 0, and m equals 6 would make the denominator 0. Alright, I'm glad I got that off my chest. I hope that this is helpful for some of you.